The United States continues to pace advancements in ballistic missile defense to track and intercept ballistic missiles. The ground-based mid-course defense, Aegis ballistic missile defense, and THAAD systems can detect, track, and intercept ballistic missiles. In this example, the Aegis destroyer tracks a ballistic missile in space, launches the SM-3 missile, and intercepts the ballistic missile before it re-enters the atmosphere. Traveling at velocities greater than Mach 5, hypersonic glide vehicles fly at lower altitudes and are more maneuverable than ballistic missiles, allowing them to maneuver after launch in a way that evades radar tracking and intercept. The DoD, U.S. government agencies, and Congress consider hypersonic glide vehicles and ballistic missiles possessed by potential adversaries as a significant threat to national and regional security. Per the 2017 NDAA, the Director of the Missile Defense Agency shall serve as the executive agent for the Department of Defense to counter hypersonic threats that may be employed against the United States, deployed forces, and allies. Responding to the regional hypersonic threat, the U.S. Missile Defense Agency has risen to the challenge, developing a concept that utilizes a multi-layered solution to defend against the next generation of hypersonic glide vehicles. This animation will highlight a series of intercepts that occur throughout the trajectory of the hypersonic glide vehicle. The glide phase intercept will engage the hypersonic glide vehicle during the glide phase of the trajectory using three methods. The Standard Missile 6 will engage the hypersonic glide vehicle during the terminal phase of the trajectory. This concept provides multiple opportunities to engage hypersonic glide vehicles and provides a layered defensive strategy. In this example scenario, the HBTSS detects the threat launch and communicates to BOA. BOA processes HBTSS detection data, and C2BMC integrates additional sensor data. The Space Communications Layer relays messages and data. The Aegis destroyer provides tracking and intercept support. The Aegis destroyer launches the glide phase interceptor to intercept the hypersonic glide vehicle during the glide phase. The Aegis destroyer launches the SM-6 to intercept the hypersonic glide vehicle during the terminal phase. And the aircraft carrier is the high-value asset to be protected. These assets will be integrated to provide a layered regional defense against hypersonic glide vehicles. 4 hypersonic glide vehicle launches occur in succession. The HBTSS detects the initial launch and the first, second, and third stages of separation. The HBTSS data is continuously relayed to BOA. BOA uses real-time data from HBTSS to create a track of the hypersonic glide vehicle. Aegis receives HBTSS track data on the hypersonic glide vehicle from BOA and C2BMC via satellite communication. The HBTSS detects and provides fire control quality track of the hypersonic glide vehicle after being released. Positioning and tracking data are continuously captured and sent through the HBTSS to BOA, then sent through the Space Communication Layer to the Aegis destroyer. The Aegis destroyer uses remote tracking information from the HBTSS to plan and engage on remote. Cleared for the engage on remote defense, the Aegis destroyer launches the glide phase interceptor. A glide phase interceptor, or GPI, is capable of engaging hypersonic glide vehicles in the glide portion of flight and overmatching the speed and agility of hypersonic threats. As the Aegis radar is out of the range of the hypersonic glide vehicle, the GPI obtains tracking data from the HBTSS relayed through the Aegis. The GPI intercepts the hypersonic glide vehicle during the glide phase. As the second hypersonic glide vehicle is progressing into the glide phase, the Aegis destroyer continues to receive tracking data from the HBTSS. The Aegis destroyer executes a launch on remote defense, launching the GPI. When the hypersonic glide vehicle is within the Aegis destroyer's radar, the GPI receives tracking information from the Aegis radar. The GPI intercepts the hypersonic glide vehicle. Alternatively, a forward-based Aegis destroyer can acquire and track the HGV during glide phase. The forward-based Aegis destroyer communicates to another Aegis destroyer to perform a launch on remote defense. The launching Aegis destroyer relays the remote track to the GPI until the threat is acquired by its radar. The launching Aegis destroyer uses its radar to complete the engagement. The third hypersonic glide vehicle is attempting to evade the Aegis destroyer's radar range. The Aegis radar is cued from the HBTSS tracks and acquires the threat on its radar system. During this cued organic defense, the Aegis destroyer plans the engagement, launches the glide phase interceptor, and completes the intercept using radar tracks from the Aegis radar system. The last and fourth hypersonic glide vehicle is approaching the high-value asset, attempting to avoid the Aegis radar system. The Aegis destroyer receives tracking data from the HBTSS. The hypersonic glide vehicle enters the Aegis radar during the terminal phase of the trajectory, and the Aegis starts to plan a cued organic defense using the SM-6 interceptor. The Aegis destroyer launches the SM-6 to intercept the hypersonic glide vehicle before it reaches the high-value asset. This scenario example showed a regional defense concept for defending against hypersonic glide vehicles using an integrated architecture of space and surface sensors working together to engage hypersonic glide vehicles in both the glide and terminal phases of flight to provide a multi-layer defense against hypersonic threats.